Welcome to iSpeakMath. This video is a FSA Grade 5 FSA Mathematics focusing on whole number operation. It is recommended that you pause each question and try to answer it on your own. Press play to see if your answer lines up with mine. Remember, this is a review and an opportunity to see where you're at before you take the FSA this year. So make sure you grab a sheet of paper and a pencil and we can get started.
Question 1 says, a multiplication expression with the product of 26,528 is shown. And then they give us our question for the multiplication. Now, our key word here is going to be product, right? We want to remember that our product just means that it is our answer for multiplication. I'm actually just going to go ahead and put a little rectangle around it so I can remember, right? And they actually give us our answer for multiplication, which is 26,528. Because this problem's a little different. They don't want us to solve for the answer to this multiplication problem. They actually want us to figure out the missing digit for this factor. So there are two methods that you can use to solve. You can either plug in each and every one of these digits into your rectangle until you find your answer of 26,528, or I could remember that multiplication is the opposite operation of division and use division to help me find that mystery number. That's the method I'm going to use today. But I'm going to use partial quotients to help me solve. So I'm going to go ahead and write out my numbers here. And I'm going to remember that my big number goes inside of my division house and my little number goes outside of my division house. Okay, and of course I'm going to draw a line here to separate the two sections of my paper. Now, 529 used to be my factor, and it's turned into my divisor. My divisor is the first number that I write out here. And then I'm going to find a number to multiply it by. Now, I like to find easy numbers to multiply it by to make my life a little bit easier. So I could either multiply it by 1 and get a really tiny number, by 10 and get a slightly bigger number, by 100 and get a number that's way too big, or I can use my little cheat sheet that I have off here to the side and know that I can multiply it by 20 and get a number that's pretty close. I know that 829 times 20 gives me 16,580. Now the other thing that I want to do when I'm on this side is to pick a shape. It can be any shape. It can be a rectangle, a square, a circle, a heart, whatever your heart desires, and you're going to put that shape around the number that you multiplied by your original divisor. That tells us which numbers we're going to add up at the end. And again, I'll show you that later on. Okay, now I'm going to take this number here, the product that I had gotten when I multiplied these two numbers, and I'm going to put it underneath here, and we're going to subtract it just like we would normally do for standard algorithm. Okay, so 8 minus 0 is 8. 2 minus 8, we can't do that, so we have to go next door and borrow. The 5 turns into a 4, and the 2 turns into a 12. 8 minus 12 is 4. 4 minus 5, can't do that. The 4 is too small. We're going to go next door, make the 6 into a 5, the 4 into a 14. 5 minus 14 is 9. 5 minus 6, cannot do that. The 5 is too small. Go next door, borrow one last time, turn the 2 into a 1. The 5 turns into a 15. 6 minus 15, or I'm sorry, 15 minus 6 is 9. Now you can go ahead and put your 0 next to your 9 for 1 minus 1 if you want, but I like my answers to be simplified, so I'm going to keep it as is. Now I'm going to go ahead again because 9,948 is not smaller than my divisor of 829. I'm going to keep multiplying on my other section. So I'm going to go ahead again and write out my divisor of 829, or my original divisor, now a factor. And I'm going to multiply it by a number. Now, again, I know that if I multiply it by 20, it's going to be way too big because I cannot take 9,948 and subtract it from 16,550. So I'm going to take the number 10, and again, shape of my choice, around it, and multiply it by 829, which I know is going to give me 8,290. Now, if you're thinking, whoa, you're going way too fast, Don't forget, you can always pause and multiply it off to the side to find your missing number here. So again, I'm going to take that 8,290 and I'm going to put it under my number here to subtract them. All right, and I'm going to go ahead and subtract. 8 minus 0 is 8. 4 minus 9 cannot do it, so I'm going to go next door to my 9, borrow to make it an 8. My 4 turns into a 14. 9 minus 14 is 5, and 8 minus 2 is 6. 9 minus 1, or I'm sorry, 9 minus 8 is 1, jumping ahead of myself there. And then again, I noticed that my difference is smaller than my divisor. So I'm going to come out here again, and I'm going to write 829 times something is going to hopefully give me 1,658. But I'm going to pause right here for a second. I've noticed that this number looks oddly familiar and similar to this number. So I wonder if there is a way that I can, figure out this mystery number here that I have to add. I noticed that the only difference between the two numbers is this one here has a 0 at the end and this one here doesn't. Well, when I multiplied with the number with the 0 at the end. And remember, whenever you're multiplying with the number with the 0 at the end, you multiply, for example, here would be the 2 times 829, and then you just add your 0 at the end. That means that 829 times 2 is this number without the 0, which is this number. That tells me that my mystery number here is going to be 2. Now, if you're like, whoa, that was way too much, I'm not going to have that every time, don't forget, you can always pause and do your multiplication out to the side. Another method you could have done is 829 times 1, and then 829 times 1 again. Okay? 829 times 2, we just discussed, is 1,658. Okay? And then you're going to bring it over here. Oops. Oh. And then you're going to subtract. Of course, this is going to give us 0, and we are done with this section. You might be thinking, wait, how do you know that we're done? Well, let's not forget we're looking for that remaining number, right? If your remaining number is 0, then you know that you are done dividing. If your remaining number is not 0, but it happens to be smaller than your divisor, then you know that you have a remainder. We don't happen to have a remainder, but it is 0. So we're going to go on to our other digits here. Because remember, we're trying to look for what goes in this mystery rectangle. So we're going to take 20, our 10, and our 2, and we're going to add them all together. 20 plus 10 is 30, and 30 plus 2 is 32. Now, if you remember, we always want to solve for what they are asking us, not for what we want to give them. And if you notice, none of these answer choices are 32. They gave us the 2 in the ones place. We're only looking for the digit in the tens place. The digit in our tens place is 3, so your answer is C. Question 2. Megan followed these steps to evaluate the expression 45 plus the difference of 30 minus 5 divided by 5. These are the steps that she did to find her answer. 30 minus 5 equals 25, 45 plus 25 equals 70, and 70 divided by 5 equals her answer of 14. Sarah looked at Megan's work and informed her that she made a mistake. Now this is a two-part question. Okay? Your part A is asking, is Sarah correct? And part B is asking us to evaluate the expression. Now, let's remember that we have two different people in this problem. Sarah is the person looking at Megan's work here and is telling her that she made a mistake. So, if Megan did make a mistake, our answer would be yes. If Megan did not make a mistake, our answer would be no. Now, this question is actually very interesting because we're going to use part B to help us solve for part A. Let's get started. Now, this is a problem that has multiple operations. So that means that we are going to use a little something called the order of operations. For order of operations, I like to use what is called PEMDAS. Some of you might know it as please excuse my dear Aunt Sally. Both are correct. The P is for your parentheses or any grouping symbols. Your E is for your exponent. Your M is for your multiplication, and your D is for your division. Now, whenever you're looking at a problem for the multiplication division, this one is actually for whichever one comes first or left to right. Addition, the A is for addition, and the S is for subtraction. And again, for these two operations, it's whichever one comes first, also known as left to right. The next thing I like to do is to actually rewrite out my expression. It helps me later on when it comes time for me to check my work. Okay. The first thing it tells me to do is my parentheses. So I'm going to look over at my problem and see, do I have any parentheses? And I see that I do. 30 minus 5 is 25. Okay, I'm going to come over here and I'm actually going to cross it off my little list. Then I'm going to come back to my problem and rewrite all of the operations and the numbers on either side. I'm going to look next to see, do I have any exponents? And I do not. So I'm going to go ahead and cross that off my list. Then for multiplication and division, whichever one comes first. Well, I only happen to have division. So I'm going to go ahead and divide 25 divided by 5, which gives me 5, and rewrite all of my other operations and numbers, and cross out my multiplication and division off my list. And then addition and subtraction, whichever one comes first. And again, we only have one, which is addition, and 45 plus 5 is 50. So I'm going to go ahead and cross off addition and subtraction off my list. Now, this is not my answer. My answer is asking, is Sarah correct? Well, remember, Sarah said that Megan made a mistake. And we see that Megan's method of solving is different than ours, but that her answer is also different than ours. So Sarah is correct in that Megan did make a mistake. Part B wants us to evaluate the expression. Well, we did. And our answer was 50. So your answer for part B is also 50. Okay, question 3 says, find the quotient. 8,963 divided by 5. Now, if you remember, the word quotient, all it really means is the answer for our division problem. So it's really just the answer for division. So we're going to go ahead first here and write out our division problem. Because I don't know about you, but I cannot solve that in my head. The little number goes outside of the division house, and the bigger number goes inside of the division house. Now, I don't like to write my comma when I write my numbers in this using this method, but if you do want to write your comma, don't forget it goes right here in between the 8 and the 9. The other thing I like to do before I even get started, before I jump in, by the way, we are using standard algorithm for this problem, is I like to write out my steps. Okay, so the first step I do is divide, then I multiply, and then I subtract. I bring my digit down, that is next to the digit I just worked with, and then I repeat all of the steps right back. So it's kind of like a little circle, right? A little cycle. You divide, multiply, then subtract, bring down your digits, and you repeat it all over again. So let's go ahead and try this. We're going to go ahead and divide 5 into 8. I know 5 goes into 8 one time. 5 times 8, because that's my next step, is 5. Right? So 8, next step, minus 5 is 3. And then my step after that is to bring down the next digit, which is 9. 5 goes into 39 7 times. So I put my 7 at the top because that's where my answer goes. And let's remember we're dividing, right? So any number that we are dividing goes at the top. 5 times 7 is 35. I'm going to write down my 35 down here. Next step is to subtract. 39 minus 35 is 4. And then I bring down my next digit, which is 6. And we do it all over again. 5 goes into 46 9 times. So I'm going to put my 9 up here at the top. 5 times 9 is 45. And then I subtract, which gives me 1. 46 minus 45 is 1. And I'm going to bring down my 3. 5 goes into 13 just 2 times. And 5 times 2 is 10. Now, if you notice here, I'm stuck with the number 3. However, there is nothing else for me to bring all the way down from over here. What are we going to do with this 3? Well, I'm actually done dividing. The reason that I know that I'm done dividing, even though the 3 is not a 0, I see that the 3, which is my remaining number, is smaller than my divisor of 5. Whenever your remaining number is smaller than your divisor, that means that you are done dividing. So what am I going to do with my remaining number? Well, I'm going to make it a remainder. I write my remainder by writing a little r and then my remaining number, which is 3. So your final answer, oops, it disappeared. Your final answer is 1,792, remainder of 3. Question 4 says, to evaluate the numerical expression, 15 minus 25 divided by 5 plus the difference of 27 minus 9. Again, this is another order of operations, so the first thing I'm going to do, either horizontally or vertically, is to write out my PEMDAS. I'm actually going to do it vertically this time, just so we can have a visual. And again, if you don't know it as PEMDAS, you can always say, please excuse my dear Aunt Sally. It's not wrong, it's just different. The P is for your parentheses or any and all grouping symbols that you have. Your E is for your exponent. Your M is for your multiplication. Your D is for division. And remember, it's whichever one comes first or left to right. I'm actually going to write it as whichever one comes first. Again, if you write it as left to right, you're not wrong. It's just, different. The A stands for addition and the S stands for subtraction. And again, we're going to do it again, whichever one comes first, also known as left to right. The next thing I like to do is write out my entire expression. This comes in handy later when it comes time to check your work. All right, and now we're going to look at our order of operations because it literally tells us the order in which we're going to do all of these operations. So the first thing it tells me to do is to work with my parentheses. And so I'm going to go back over to this problem and see if I have any parentheses, and I do. 27 minus 9 is 18. Okay, I see I have no other parentheses, so I'm going to go ahead and cross out the P. And I'm going to go ahead and rewrite all of my remaining numbers and operations. My next step is to look for any exponents. I see that I don't have any, so I'm going to go ahead and cross it out. Multiplication and division, I'm looking for whichever one comes first. Ooh, I'm lucky I only have one division problem, which is 25 divided by 5, which gives me 5. And again, I'm just going to write that number first and then write out all my remaining operations and numbers. Then I'm going to come over here and cross those out. Then I'm going to look for addition and subtraction, whichever one comes first. Now, if you notice here, even though, in the order of operations, it's addition, then subtraction, again, we do whichever one comes first. So subtraction actually comes first in this problem. So we're going to do 15 minus 5, which is 10. So now we have 10 plus 18. And I'm actually going to come over here and cross out my subtraction. 10 plus 18 is 28. I cross out my addition, and that is your answer. Question 5 says to find the product. 6,432 times 13. The first word that we want to look at that's a little different is the word product, right? And if we remember, product just means the answer to multiplication, right? So it is the answer. Multiplication is a big word, so we're just going to draw it over here. The answer to our multiplication problem. So we're actually going to use standard algorithm to solve this problem. So I'm going to go ahead and write out my 6,432. And again, I like to kind of space out my numbers. If you like them a little closer together or with your comma, go ahead and add that in. But I like to space it out so I can really keep track of what I'm doing and make minimal mistakes. And line up all of my numbers, of course. The first thing we're going to do is take 13 and kind of break it apart. So we're going to first multiply the 3 by the 2, right? So 3 times 2 is 6. This 3 again times the 3 at the top is 9. The 3 times the 4 is my 12. Now I'm going to put down my 2 and carry my 1. Some of you know it first as carry your 1 first, then put down your 2. That's all right too. Then you have your 3 times your 6, which gives you 18. And then don't forget to add your little 1 at the top, which gives you 19. All right, but we're not done yet. That was just the 3. Now, if this helps you, some of you, it might help to cover up the 3 now that we're moving on to the 1. That's something that you can do. I'm going to just leave it out, okay, for now. The next thing that we're going to do is actually make sure that you put in your 0 placeholder before you go in and start multiplying anything else. Then we're going to do 1 times 2, which is 2. 1 times 3, whoops. 1 times 3, which is 3. 1 times 4, which is 4. And 1 times 6, which is 6. Okay? Remember, multiplication is just repeated addition. So we're just going to add these together. 6 plus 0 is 6. 9 plus 2 is 11. Now, whenever I have a series of numbers like this, I actually like to group them to see which one is easier. So I know that 1 plus 2 is 3, and my doubles, 3 plus 3 is 6. So I group it that way and know my answer down here is 6. 9 plus 4 is going to be 13. Again, put down my 3, carry my 1. If you like to carry first, that's okay too. 1 plus 1 is 2, and 2 plus 6 is 8. Okay. Now I'm going to go ahead and count and do 1, 2, 3, and this is where I put my comma. And my answer is 83,616.
Hope you enjoyed this FSA review video. Remember, you got this. I am a firm believer that practice makes perfect, and I know you'll do well on the FSA. Please make sure to like this video if you find this video helpful for your FSA journey. And remember to subscribe because more videos are coming out. Hope to see you soon. Take care.